This is Liam for Humanitarians AI, and this is Fellows, the series where our fellows show their work. I wondered what fellow Ushasvi Rachel Peeka has been building lately. The answer is Causal Couture, a system that reads a small shop's own data, sales, inventory, social, web, and works out what is actually driving the business. This week it grew its decision layer. Here is the shape of it, and then the report in her own words. First, the foundation, because she built this in order. Phase 1 was the skeleton, a backend API, a front-end and CSV upload with schema validation, required columns, date formats, SKU ID, all checked before a single row gets in. Phase 2 was the pipeline, files cleaned and standardized, rolling sales averages, spike detection, and everything combined into one unified date-by-SKU view of the whole business. Phase 3 is the part that thinks. A starter analysis engine reads that unified data set and generates demand, inventory, engagement, and conversion signals, then rolls them into an overall business health score and an initial inventory recommendation. One scorecard for the whole shop, and notice her own label on it, heuristic starter scores before full causal effect modeling. She knows exactly where this is on the road. And because a score without a sentence is just a number, she added a plain English interpretation. The system explains its results in business language, not analyst language. Next on her list, replace the causal heuristics with real causal modeling, add scenario simulations for inventory decisions, and head toward the conversational interface that is the end goal. Here is Ushasvi's Phase 3 report, about 5 minutes, unedited.
My weekly progress update for Causal Couture. This week I focused on primarily building the first version of the Phase 3, which is the decision layer, which is very much the core analytical part of the project. I started by implementing a starter analysis engine that generates demand, inventory, right here. Engine that demands inventory, engagement, and conversion signals from the process business data, and it sort of creates a unified data set from all of those that combines all of these signals into an overall business health score and provides a really good initial inventory recommendation. This is the scorecard. I also added a plain English interpretation right here, which would help the system translate the analytical results into a very business-friendly insight instead of just returning the numbers, which it does over here. And just to have a little bit of background of what the project was like since the beginning, reminiscing the Phase 1 and Phase 2. For Phase 1, I built the local project foundation, including the backend API, the front-end interface, the data schemes, the CSV upload with schema validation, which helped the system validate required columns, date formats, SKU IDs, and the different numeric fields before proceeding to any upload data. For Phase 2, I implemented the ingestion and pre-processing pipeline, uploaded files that are cleaned, standardized, and transformed into processing data sets. I also added basic feature engineering features, including rolling sales averages, sales spike detection, etc., to make the data set much easier. And then I finally built a unified date-by-SKU dataset that combines all the different features like combined sales, inventory, social media, and web analytics into a single analytical view for a downstream reasoning. I also spent quite a bit of time improving the user experience. The palette or the theme is just something that I was tweaking around with, which I'm definitely going to change. But yeah, coming back to the user experience, I spent time by redesigning the front end into a very polished interface, and then integrating the complete workflow from the file upload through the scorecard generation right here, and the business explanation. The current prototype is now working pretty well end to end locally, and I've pushed all the implementation to my GitHub on the repo. Next week, I will be focusing on strengthening the causal reasoning layer by replacing some of the causal heuristic logic with a much more robust causal modeling, which will definitely improve the feature engineering, adding different scenario simulations for future inventory decisions, and moving closer to the conversational chat experience, which is quite the end goal of what Causal Couture is. I'm going to run through the demo for just a second so you would understand what this works like. So you're just going to go ahead and upload different files. For example, I'm gonna upload the sales file and it's gonna process the data set, and then I'm gonna go ahead and upload every single one of these files. Now that all our files have been uploaded, it's just going to create, you can go ahead and select the specific file that you want to create a uniform file, but these are all the files that I have used before. And then you're just going to go ahead and build the unified data set, which is going to give you the unified data set, and then you're just going to select the unified data set, put the file name and run the starter analysis, and then it's just going to give you a scorecard, and then it's going to run the explanation. Since it's the same data set, it's not giving me much of a difference, but it is the same values and results overall. And yeah, this concludes my work for the week, and I will update back next week. Thank you.
Professor Bears notes the feedback first. 3 phases in this is a real end-to-end prototype, upload to unified dataset to scorecard to explanation, and the discipline shows. Validating schemas before ingestion is the unglamorous choice that saves you later, and date-by-SKU is the right grain for this problem. The plain English layer says you know who this is for, now the push. Today, causal is a promise, not yet a property. The engine is heuristic signals and a composite score, and to your credit, the interface says so on screen. But a health score has to show its work, which signals moved it, weighted how, based on what. And next demo, bring 2 contrasting data sets. Running the same file twice can't show the explanation layer earning its keep. The next steps: 1. Pick a single narrow causal question. Does a social spike cause add to carts or just travel with them? And answer it properly before generalizing the layer. 2. Start scenario simulation with 1 decision, the reorder quantity on your top SKU. 3. Define the validation story, backtest recommendations against the 6 months of data you already have, so it works as a measurement, not a feeling. Ushasvi Rachel Peeka, Humanitarians AI Fellow. The code is on her GitHub. Your turn, paste this into Claude. Here are 6 months of my shop sales, inventory, social, and web numbers as CSVs. Build 1 unified daily view per product, score the health of the business, then tell me which signals merely correlate with sales and which plausibly cause them, and what you would check before trusting any recommendation. That last clause is the whole game. Causal Couture exists because correlation is cheap and decisions are not. Run it on your own numbers and watch where the explanation gets uncomfortable. That's where the real causal work starts. What's Ushasvi building? Causal Couture. This has been Fellows from Humanitarians AI. Liam for Humanitarians AI.